Let's talk about something that really grinds my gears. Okay, I'm trying to sound like Peter Griffin, but I'm not doing a good job of it. And I've got to be careful because I've got my live on at the same time, so I'm probably going to get caught when I keep looking in the wrong place and thinking, why doesn't that work? Any case, what really grinds my gears around the science deniers is really quite simple. Hi for the Mycopium Emporium. They keep saying there's a special chip in it that shows you what they want you to see. But there's something about that doesn't make sense. And it doesn't make sense on several levels. If the chips had something in them that would predict what you wanted, worked out where you were when they're completely unpowered, when they've got no special circuitry in them, and they don't work as designed, this wouldn't work. Seriously. Nothing would work. The computer and the phone and the devices I'm using right now would not work because they can't work as designed. Let's explore this. Let's begin with, just take us into this one. This is my background. This is what I've been doing since about the age of 7 or 8. It's not something that is new to me. I think it's really important to establish what I'm talking about. Now, some people have different ideas, but this is the basics of electronics. You learn about components, insulators, conductors, semiconductors. You do AC, DC. You do capacitance and inductance and what happens when they're in AC circuit. You start covering power, radio frequencies, different types of oscillators, different types of circuits. You get to a point where you understand this pretty well, even without Faraday's and Maxwell's equations. You don't need them all the time. 99% of the work I do doesn't require me to have that level of math. But I'm starting to learn more about it as I've been progressing through this. And the first one that surprised me, the fact that the time dilation is not hard to see how it works. And what's interesting is that very simple formula tells you the time dilation, and guess what? It works because satellites for GPS use it. But I'm digressing away a bit from where I wanted to go. And why you guys grind my gears all the time. So the claim, NASA makes special chips to show you what you want to see. GPS works because blah, blah, blah. Now let's look into that. I actually own this manual. The manual that you're seeing right now is a partial front page. Blue, you had ones for logic, one for CMOS, transistors, larger scale integration. All of it were put into these manuals. The manuals just give you information, but they showed us the schematic. We could see pin to pin what that is doing. We can read the diagram, and there's no assumption from the designer about how you will use this. Otherwise, you're going to make an absolute ass of yourself. The other thing they have is table upon table upon table of information. Maximum voltage, minimum voltages, frequencies, what to expect, rise time, fall time, current, fan out. All of this is part of the circuit operation, and if you don't use it properly, if you don't read the data, you cannot make your circuit work. And if the circuit did not work as I'm showing you right there on the screen, you couldn't make anything work. I said before, this wouldn't work properly. Something I designed myself wouldn't work properly. I wouldn't be able to succeed at building anything I've designed. Why? Because this piece of paper is a contract between the original designer of the chip and the planet. Everybody goes to the same spec sheet and reads up on it. So this matters because, and I just said it before, it's a binding contract. In order for me to know inputs and outputs and what to expect, it has to match the spec sheet. It's simple as that. If it doesn't match the spec sheet, it's not going to work in a circuit. And before someone says, oh, but blah, 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 these things were designed in the 60s and 70s, and they haven't changed. These are 7-segment BCD to 7-segment LED devices. They actually decode BCD to decimal, so you can read it. They were around as a chip. They were around back in the 60s. They were being used extensively in 60s and 70s, a space program as an example. And I'm just going to harp on these points. You're saying that the original designer thinks he knows what I'm using that chip for. You've just suggested that they've envisaged my use, someone else's uses, and that's absolute garbage. There's no way that that person could have anticipated how I was going to use it, where I was going to use it, what I was going to ask it to do for my application. That's how this works. Chips are just building blocks and we assemble them into a circuit. So the other thing to think about, how can something which is this big actually have the circuitry in it to identify where it is, identify everything around it, and still function the way it's supposed to function? So let's look at an example, and I've just got to swap my screen over to my favorite tool set, and we'll go through that. Lovely. Come on. Okay. Wasn't quite supposed to happen that way. This is supposed to give me the schematic. Supposed to be a different one here somewhere. Sometimes I get a little surprised and these things need a small reset. There's a secondary one that's not giving it to me. Okay, let's kill and restart. The KiCad tool does what it's supposed to do, but yeah, it's not being cooperative, even though I want to show you the schematic. And I don't have a second screen, so I can't opt for just a whole screen. There it is. Took a moment to bring it up into play. So what I've done is I've designed my own application, and I worked out what my problem was that I wanted to solve. I looked at the different ways you could solve the problem. By the way, that schematic is for this board. You can't make the board until you've got a schematic because the complexity of the connections is pretty big. So let's explore a couple of the chips and just see what we can find out. Okay, starting over here, crystal oscillator. This device is basically a ripple counter, and all it does is divide down. If this is 32 kilohertz input, more precisely 32,768 hertz, and it divides it down, and it divides it down to 2048, and divide by 2, divide by 2, divide by 2, till you get down to 2 hertz. It doesn't do anything else. It can't magically just give me the frequency I want automatically, because that's not what was designed. They designed it with all these outputs from its internal structure. So when they make the lithographic plates and etch the silicon, dope it, all that stuff, it becomes this circuit. Can't be anything else. Let me just swap back to this one, and let's give you a closer look at this. You can clearly see where the LEDs are sitting on this. Directly below that are the resistors, which are used to current limit. Directly below that, BCD to 7 segments. And then there's these other chips. There are 3 here, which are managing a particular segment of the work. And down here, oh, I've got to get used to this left and right thing. Right there are the 2 chips that I just displayed in the other one. It's on the other screen. So let's go back to the schematic. So those 2 chips there, those 2 chips are the 2 chips in the schematic. Now I've labelled these sections so it's a bit more obvious what we're talking about. So let's move on to the slot where we've got 3 chips. I'll just adjust the size of this a bit. Yeah, trying to get this to fit all in. Right, it's a little hard to see, but that's 1 chip, that's the 2nd chip, and further over is the 3rd chip. That's the 3 horizontally across there. All these chips do is receive the 1 hertz signal at one end, being this end, and as it counts above a certain value, it simply passes the signal on at specific points. So this does 0 to 9, and when Q4 goes from high to low, that's when it's gone from 8, 9 back to 0. That passes the signal on to enable with the clock grounded. That makes this chip increment by 1. These 2 points here, if you look at it, Q1, 2, 3, 4, when you reach 6 in binary, it's 0, 1, 1, 0. At that point, and only that point, does the AND gate activate and hits the reset. So this thing counts 0, 1, 2, 3, 4, 5, 0. It's forced to follow that count. It can't do it any other way. Keep working our way across, and we've got the last piece of circuitry, second last. That was seconds. Now this is minutes, and it looks surprisingly very similar to the first section. There is no person on the planet would have said, oh, you'll only use it in this type of application. There are hundreds of thousands of applications of circuitry like this, not just a clock. That's what this one actually is. It's just a 6-digit clock, hours, minutes and seconds with a 12-hour reset. Because this is so similar to the previous stage, it's just simply 0 to 9, and when you go from 8, 9, 0, this drops back down to 0 and feeds forward and passes on a pulse to this one. And as I said before, same thing here. When Q2 and Q3 are both a 1, and in 0 to 9 that can only happen at 6. Then the AND gate sends a pulse back which forces that to shut down. At the same time, the AND gate's also fed forward to the next section, and it's behind my image, and it goes into that chip and makes it increment by 1. So the sequence is once a second. I think I accidentally moved something in my schematic. Any case, so once a second, once every 10 seconds, once every minute, once every 10 minutes, once every hour, and once every 10 hours. So it slowly clocks over 0 to 1, and guess what? As soon as you go above a certain point, these two combined, which is when this is a 1 and this is a 2, 0, 1, 2, that applies a reset. These two get reset back to 0. That's it. 0 to 11 midday flips over. Yeah, so that's it. It's just a 12-hour clock. After that, the binary coded decimal coming out goes to the converter chips to drive the LED displays, and just tells you what each of those chips is producing on their two outputs. Now that's just a pretty simple example, and there's way more complicated pieces of kit than this. I think my image is behind. All right, let's go back. So that's all it is. But to get to this, you have to create the circuit. You have to know what each chip does. You have to understand how the timings work, how resets, enables, and clocks work. And if they don't work as designed, this design would never do what it's supposed to do. That's a simple one. These wouldn't function. The computer that's bringing you this image, my voice, and drives YouTube and other social medias would never work. They even say it about telescopes, which have only got glass and metal. So guys, show me the power supply, the GPS receivers that position it. Show me the wiring. Show me all the things that would make an electronic circuit that would show me what they want me to see. And I know that's a really hard question you can't answer. So bravely run away and enjoy your cope. I really should have put the this microphone scratching on there. I should have put the little fuzzy on. All right, not to worry. That's my little grinding my gears today. A couple of other things that come up just outside the electronics are the usual rigid aircraft over a flat and rotating Earth, under the section called Assumptions. And I had a beautiful discussion with a gentleman on X going, "Oh, but do you agree with me because it says this?" Actually, I'm not disagreeing with you. Your own evidence says it's an assumption, and you continue to argue that the world is flat when it's an assumption made to simplify the math. Funny how these people keep pulling up these old things. So to beat them at their game, all we have to do is point out what they haven't read or what they've ignored. They tend to run off pretty quick. Yeah, well, the numbers are not there, but what's left are still loud and heads buried in the sand like an ostrich. I think I've said enough. Grinding my gears just makes me do a video. Gentlemen, enjoy your day. Ladies, enjoy your night. Good evening, good afternoon, wherever you may be, apparently. I've got to say toodles and have a good night, guys.
In the chat like he's running the game. Ask a fake question, then deflect the blame. Truth hits hard, but he don't wanna learn. Rather gaslight and watch the logic burn. Dick Wayne is a disingenuous,